two phones up here. I don't know if that's causing a problem. Testing, testing. Welcome. We still have a lot of time left, so relax, take a nap. So I usually back up to like here. Stuff. So I usually back up a little bit. I don't move too much, but I rock. I talk loud. Is this good? Disappointed, Sam. Well, it was founded in 14 something. I played there in the 1600s. I was a prop, which is basically all I have now. I don't even know a word. I'm trying out a new app for displaying my slides, so if it blows up, take lots of pictures. Good to go? All right, my voice is a little bit messed up from screaming at Vanilla Ice all night, so if you can't hear me, I do talk loud, so just tell me to speak up. Welcome everybody to Hacking Mobile Apps with Frida. This is intended to be a beginner's level course, getting you started from zero, going up to looking through some applications and kind of figuring things out on your own. So if you're already an experienced mobile reverse engineer or hacker, you're probably going to get bored, and if you feel the need to leave, I will hunt you down like a wounded animal. So the alternate title for this was Hacking Mobile Apps with Frida and the other tools that are based on Frida, which don't always advertise it. Because as you'll see through this ecosystem, Frida is really the central kind of linchpin for most of these. So just a little bit about me, because that's what we do here, is I'm the pen test lead for Allstate. So you can probably imagine that we have a few apps and a couple servers, and we generally stay fairly busy. Before that, I was a pen test consultant, specializing primarily in software and mobile devices. And so I've been doing software pen testing for about 5-ish years, and then software security before that. Before that, I went through lots of different types of security and operations and engineering. I had my little CCNA, and I started out life as a programmer. So I've kind of been on both sides of the team, and I've been the developer, and I've laughed at the developers. So Why does that make me qualified to talk about mobile hacking? Because primarily, I'm not some kind of reverse engineering wizard, okay? I, I have to figure things out and take the hard way and struggle and fail. And I feel like I do a pretty good job of teaching people where I have failed and banged my head on the keyboard for days at a time to help you avoid that. So now half of the rest of the other half of the class is like, that's great, what are we doing here? So raise your hands if you have a flip phone. 2. All right. Raise your hand. That's the first time that's ever happened, by the way. Raise your hands if you've got one of those little prison phones. Yeah, this guy knows what I'm talking about. So the rest of us, except for you two, have apps, right? And maybe we just want to mess with this stuff for fun. Maybe we're looking to do it for work. You know, maybe you want to grow your skills and just make some money, get those sweet iOS O days. So everybody kind of goes the same direction. And so I went and listened to Joff's talk yesterday, and that was a very good basic talk for getting into Android pen testing. Everybody kind of goes the same direction first, right? Traffic analysis, looking at what the application is doing. You want to know what's being sent to the server. And a lot of people get to mobile from web pen testing. And so it's just a natural progression to want to burp all the things. So does anybody use anything besides burp for traffic analysis? Yeah, there's Zap. There's another good one called Surge. Fiddler, maybe, if you use a lot of Windows. These are great for looking at the APIs, for seeing what communication is going out. Now, I'm going to hide a little bit when I say this. Burp has flaws, right? Maybe it's not capturing the kind of traffic that you need, right? Maybe it's already encrypted by the time it goes out over the network. And there are definitely ways around that. Maybe now people are using SSL pinning, right? That's starting to get a lot more popular than it was even 6 months to a year ago. Now, the next natural progression, if you're doing this for work, if you're trying to perform some kind of pen test for compliance or whatever reason, configuration analysis, right? This is looking at the build environment, looking at the deployment environment, and checking all the boxes and making sure that when this app gets deployed, the backgrounding images are not leaking PII, that we don't have insecure data storage in an unprotected SQL database. We don't have passwords in text files. So the configuration analysis is very important on the defensive side, but it's not really fun. You're not going to sit around and look at backgrounding images. Now, everybody's favorite, the next natural step in mobile pen testing is static analysis, right? So you're definitely either doing this for one of two reasons. Either you work at the company that owns the app and you're looking at the source code, or you really hate whoever made that app. And you're pulling it apart and trying to figure out what's going on inside so you can kind of, figure stuff out. So almost everybody stops there, right? You're donezo. It's the 80-20 rule. I got the 80% out of the way, and especially if you're doing this for a pen test, like when I do it, I got a week, right? So it's a smash and grab. I got to do as much as I possibly can in a week, and reverse engineering does not come into play. So I think everybody in this room knows that what's next, right? There is still a lot of dirty stuff going inside these mobile iOS and Android applications. He did a poll yesterday and it seemed like most people had Android. iOS is not quite as dirty because the App Store is not as open as Android, right? But you still see apps that are just doing things that you don't want on your phone. Facebook. This is where Frida comes in, right? So what is Frida? If you've not used it before, it's an open source dynamic instrumentation framework, which basically means you can see what's happening in runtime analysis. Now, it is not a debugger. You're not going to attach to the application and step through line by line and watch the execution. This is function hooking. So once you've done a little bit of reverse engineering and you're finding some information that's kind of inside the application, function names, pointer addresses, things like that, you can figure out what you want to change. And because it's all at runtime, you can essentially change any functionality of a running application so long as you're able to find it first, right? So it's completely cross-platform. And what can we do with it? I just said that a little bit. So hooking dynamic runtime functions. It does have the ability to go back and patch things, but that's kind of beyond the scope of this talk. Typically, you're going to be altering the functions that are running. So for example, one of the difficult things about doing iOS static code analysis on something that you don't own is the IPAs are typically encrypted, right? It's not until it's running on the iPhone that it gets decrypted, and you can extract that with Frida, pull that off and start doing the reverse engineering in something like IDA when you have an awesome license. I mentioned SSL pinning bypass. So SSL pinning, if you don't know, is a fairly new strategy of ensuring that your application, whether it be a web application or a mobile application, is only talking to one server based on the certificate that's pre-specified at compile time, right? So if I open up a mobile app from somebody who's got a really big budget, like Candy Crush Saga, they're doing SSL pinning, and so when I try to funnel that through burp, right, it's not going to work. Even if I do all the normal burp certificate stuff, even if I do the new Android methods of rebundling my certificate, it's not going to work because it's not their cert. So with Frida, we can hook that at runtime, and then the app is just like, YOLO, this whatever cert works. So I'm doing this on most of my app tests now. You know, I work with a large development shop, and they have fairly good practices, so SSL pinning is everywhere now. Another good example is reading or altering messages pre or post crypto, right? And I don't mean Bitcoin, Sam. So if a message is getting encrypted, Burp's not going to catch that, right? But if you can catch that before it gets to the encryption function or in the middle of the encryption function, you can alter it, and then the receiver is not getting what was intended. Now, this is not like some kind of magic remote code execution because you've got to have it on a device that you've already rooted or you own, essentially. So how does all this magic work? Frida has two basic modes of operation, interceptor and stalker. So they're not quite interchangeable. What interceptor does is it injects into the process a trampoline, which is a jump instruction to tell the execution to go somewhere else, right? So if you're not an assembly pro, right, it's an instruction that tells you you want to go somewhere else that you control so that you can later send it back to the original location and continue execution with the process, right? So for a prize, based on this guy's experience, who can tell me how ASLR affects the loading of the jump instruction? You don't count. How does ASLR affect the loading of the interceptor with the jump instruction if we don't know the base memory address? Anyone? So the answer is it doesn't, right? A lot of times in reverse engineering, if you don't know the address because ASLR is hopping things around, it can be tricky to find that. But we're already running it. When I turn Frida on, it spawns the app, it's already running, and I can get the base address with one command that I'll show you in a little bit. So the problem with interceptor is it's more like the breaking the window, right? We're just going right into the process, and it's easier to detect if there's any kind of reverse engineering obfuscation or protection mechanisms. You know, people do this stuff on big budget games that make a lot of money, and obviously they have something to protect. And so they do a lot of reverse engineering protection, and there's libraries out there you can include in your mobile apps that will try to prevent Frida. And so you've got to rename things and, you know, recompile, and it will generally always work, but it is easier to detect. It's a little more reliable because process injection is a known issue, and I almost never have problems getting this to work. So contrast that with Stalker, which is more stealthy, and what Stalker actually does is it takes the running live assembly and makes not quite a copy of it, right? So you can look at the copy and you're like, that is just, there's something there. And that's because it gets to branches and things that it can't follow, right? So it can only do small sections, and they have done a good job of getting Stalker to follow processes on, you know, x86 and x64. It's not implemented on 32-bit ARM, and if you're working on Android, that's important because most Android apps right now, except for the big ones like Gmail and Chrome, most of them are going to be 32-bit. Just got dark. So most of them are going to be 32-bit. Now, coming up in August 2019, Google is mandating 64-bit support for all Android apps. So that's coming. Stalker works better on ARM64, so just remember that. It is more stealthy. It's also more fragile, so it's easier to break because obviously making copies of janky assembly can cause issues. So I'm just going to walk through some basic setup of how to get everything up and running. You have to start out with some sort of workstation, right? I'm assuming everybody's got a laptop or a desktop. So if you take one thing away from this talk at all, it's virtual environment, right? When you're doing anything with Python, and especially on systems like this where there's a lot of people making a lot of different types of tools and none of them talk to each other, right? They have different dependencies, and you will bash your head against the screen. The third time, you have to blow your environment away and undo all of your Python dependencies because you forgot to do your virtual environment. So it sets up a little sandbox with all your local dependencies, and everything is magic. So you can just run through pip, install Frida and Frida tools. The tools give you the command line tools. Once you get good at like the Python scripting and the automation stuff, you might not need that, but it's just kind of fun, and when you're learning, it's neat to poke around in there and see what the individual commands do versus looking at a 500-line JavaScript file and just hoping it runs. You're going to need your development environment. Android Studio brings ADB, the Android Debug Bridge, right? And that's what sends all the commands to the phone over USB. Without that, you can't do it. Xcode and the Xcode CLI tools. Now, Apple has got the courage to make the CLI tools now a separate download. So you have to log into the developer site, go through their download page and find all the pieces that you need for your version of Mac OS and the iOS that you're working with. So that's fairly quick to get set up. We can all download stuff. The target device is very cross-platform. How many people in here have used a QNX operating system lately? No, I saw a hand over there. Do you have a BlackBerry? Yeah. So BlackBerry bought QNX. That was news to me, putting this talk together. But your target can be any of those, right? So, but we're going to cover Android first. Android is a little bit more manual. You have to go out to GitHub and get the latest release or the known working release that you like working with, right? The guy does very fast development. So I think in the 6 weeks of putting this talk together, I went through maybe 6 versions of Frida Server. So you go out and find the Frida Server. This is the server, right? So you find this for the architecture of your device, and you use ADB to push it over to the friendly data location on your device. And so then you have to shell in, chmod it so that you can execute it and run it. And if you run it with the ampersand, it'll be in the background. until it blows up, which it will. And so I generally will have ADB logcat running, and I will not run it with the ampersand, so it's in the foreground. It's not the best at log messages, so there's no -V for verbose where you can turn it on and see everything that's running. So use logcat and try to see what the Android OS is telling you is breaking, right? So if you have a jailbroken iPhone, you're one of the few right now. Did anyone? Yeah. So like 5 people here, right? So the latest jailbreak, when I did it, I had my iPhone waiting for like 4 months, and the day it dropped, I did it, and like the next day it was impossible. So if you have iOS 10.2, you can use the older jailbreaks. If you have 11.3.1, you can use the newer one. But if you do that, you can use Cydia and you just add the new source. If you're better than me, you can install apt and just do it that way. And you just install the latest from the latest package. Now, the difference between Android and iOS is you're relying on someone else to put the latest, push it up to the package source, right? So as he's doing bug fixes and one of them affects you, you might have to wait a day. He's still fast, but sometimes a day is annoying. If you are the rest of the 99% of the people in here, it still works on a non-jailbroken or a non-rooted device. The difference is you have to recompile the app. And so that means going through the Apple process of getting a developer account, making a signing certificate, making a deployment profile, getting that deployment profile into a blank, empty app project in Xcode, deploying that app to your device, and praying that it works, right? So the first time I did that, it took me a few days or a week to get everything working, right? It's not trivial, it's simple, but it's not easy, right? So once that's all done, then you have the Frida gadget that is basically a configuration file that goes into the app that tells it where to look. And so Frida behaves the exact same way if it's jailbroken or not. It just means that on your development workstation, you have to do a lot more work and effort to make things work. So now we've got to the point where hopefully we have our workstation working and hopefully we have our device. So some basic operations to kind of make sure things are functioning. Frida will wrap like the ADB, and so you can just do an ls devices to see if you're talking to things. You know, the USB connection will sometimes fail and you just have to unplug, right? You're doing weird things to these devices, so check to make sure your device is even present. Once you're doing this, you can check processes, right? The TAC capital U is for USB, so you're going to type that, at least I type that for every single command. And A is all, and if you do TAC UAI, it's everything that is installed and excludes the default apps, right? And so you can start finding the processes that are running if you're looking for a specific one. But this is just a good smoke test to make sure you're getting any kind of traffic back, right? And so what Frida is doing now is it's running a TCP server on a high port that I don't remember. So it just connects from your device over USB to that TCP process, that service, and it can do all the commands locally. So the next thing is Frida trace, this is where the stalker comes in. So Frida is looking at the process. The I is looking for a function name, right? And so this is typically like open, send, receive. These are the native functions to the Android OS. And so send and receive is like network communications, obviously. Open is for file system. And this is something that I will actually start to use these when I'm first looking at an app, and I'm just trying to understand how it works and how things are put together, right? I don't use it a ton for my testing, but when I'm trying to reverse an app and I'm looking for a specific function that I know I want to use, you can start narrowing it down that way, right? So if you've done any reverse engineering, I'm preaching to the choir, but these are just some basic things, and you can see If you put, instead of that asterisk in the TAC I, you put open, you're going to start seeing things come back. And it's usually a lot because every app does a lot of network communication, whether you know it or not. So you can start watching things. So typically in reversing talks, this is where it goes from here, right? We've got the circles, now draw the owl, okay? So it's difficult because reverse engineering doesn't translate well to slides, right? You don't want to see me up here cursing and typing commands failing for 8 minutes. So I'm going to try and run you through some less basic operations, and we'll see what happens. So when you spawn an app, right, Frida will either attach to something that's already running or it will spawn it itself. So depending on which you're doing, if it's running, you might change the F to an N and use the display name of the app. And the no pause is important because when you first spawn an app with Frida, you're going to get a CLI back, and it's going to sit there and wait for you for like 10 seconds and get bored and leave. So it's going to quit. And if you don't understand that it's waiting for you to do something, then it's just going to keep crashing after 10 seconds, and you're going to get frustrated like I did. So now you can actually start looking what's the modules that are loaded inside the application, right? So the modules are the different parts of the app that get put together to make a functioning app on your phone. When you write a mobile app, you don't write the code to deal with the screen touch, right? You don't write the code to deal with the network communications. All that is handled by the good people at Google, right? You don't write the code, you don't ever see the code to deal with your tracking and your ads and your illegal microphone operations, right? So when you start doing this, on some of these big apps, like I started trying to look at Chrome for this. It is gigantic, right? Any of these apps that have all the permissions, like Joff was talking about, if you pack the Metasploit module into your mobile app, it uses everything. So you're going to get a list like 1,000 lines long of all the modules in this app. And so generally I'll copy that from the terminal, put it in Sublime, cut out all the Google crap, and find the stuff that I'm actually looking for. And once you find a name of something or a few things that you think are important, then you're looking for the base address, right? And now you're starting to do what actual people call reverse engineering. You find the base address, and that's where that application is actually running in memory right now. So once you have this, you can start finding the offsets to the other functions. So if you've done some static analysis and you know the name of the function you're looking for, right, then you can find the offset and you can start modifying your scripts, modifying your tools to hook that specific function. Right? A lot of these are based on pointers and offsets because the app doesn't know to look for the name of the function when it's running. So once you get to the point where you've started to kind of play around with an app and you're learning how it works, you're learning the names of functions, you can do the base address, you're going to get into scripting, and this is really where the magic of Frida comes in because it's got JavaScript bindings, C bindings, Python bindings, and Node now, I think. So if you can write any of those languages, you can call the Frida API and do the exact same operations for that native device in your favorite version of code. I do most of it in JavaScript, not because I like it or I'm comfortable, but because that's what most of the internet does. And the people who are writing like the C binding code generally don't share it. Right? They're doing it for different reasons. So if you have a script that you want to test out running, right, you just do a TAC-L and that loads your script into Frida. One of two things are going to happen at this point. Either it's going to start up, it'll spawn the process and start up, and again, it's just going to be sitting there waiting for you, even if you did the no pause, because a lot of these scripts are expecting a secondary command once you're inside, right? Something like start pointer, with the base address. The other option is it'll just dump out a bunch of data and then quit, right? Like some of these, I have a script that will do the synchronous lookup of all the modules so that I don't have to spawn an app and type out the command manually. I just run the script and it dumps all the modules for me. And so it could be something as simple as this, right? Like this is changing a message that is being sent, right? This is the entire Python script. So even I can write that, and that's saying a lot. You know, they do get pretty complex depending on what you want to do. If you're looking at altering crypto stuff, if you're looking at changing the functions of, you know, significant private methods in these classes, then it can get pretty complex. But yeah, I'm just looking. I have a blank slide. That's sweet. So another thing that exists out there where people do their sharing is there's a free to code share, right? So you can just import this directly into your command line. You don't have to download the code. You can go out and look at the share site, see what you like. Typically, they get stale, right? Frida moves fast, iOS and Android move fast, so, and every app is different, right? So I do download them a lot and just modify myself and kind of get things running. For an example like SSL pinning bypass, there are a couple main libraries for SSL pinning, right? But again, if you have a big budget to protect your app, you might not use that because you know that everybody with Frida can just use the universal SSL pinning bypass script. So either you write your own or you just rename it, right? So if you get to this point where you're modifying other people's scripts to run with the functions on your app, you are starting to draw the owl, right? You're getting to this point where you are actually modifying what these apps are doing. And it doesn't always have to be complex. You know, a lot of these can be like login equals true, you know, success equals true to false, or I guess I should be vice versa. Success equals false to true, and this app lets you in, right? So there can be very simple responses to a lot of these methods. So this is not something that I typically do, not the owl. This is not something that I typically do during a normal pen test, right? Because again, I got a week, and if I'm looking at something even for longer than a week, I'm not gonna try and reverse the entire application unless I really, really care about it, right? So, show that a couple more times. So, we want to speed things up, right? Those that have gone before us in the trenches have done a great job of it. FiOS is one of my favorites, right? This is based on Frida, and this was an amazing tool for iOS 10.2 with a jailbroken phone or Android. Allegedly, it works with non-jailbroken. This was made by a guy as a college project, and then he disappeared. And so if it works for you, it's amazing. I haven't been able to get it to work in a few months, ever since I upgraded to the new jailbroken iOS. Kind of the same thing with Appmon, right? So these are very good tools. You can look at your apps and it'll give you all of those configuration analysis in one screen, right? And so if you're needing to copy all this stuff for a report, you're not manually looking through the Android manifest trying to find these switches. You just cut and paste and, you know, go about your day, go back to Fortnite. Passion Fruit's a good one for iOS. Brick is a good one for reverse engineering. Like, the guy really likes doing games. Like, he's done a lot with Clash of Clans. So he has done a lot of work for using Frick as a reverse engineering, or as a debugger for running mobile apps, right? R2 Frida is based on, obviously it's a plug-in for Radare. Is anyone in here a Radare user? No? A little bit? Has anyone here opened it? Yeah, right. So it's I consider it the second most powerful reverse engineering tool to IDA Pro, right? But what's the problem? The learning curve is straight up, right? And if you don't know the difference between AAAA and AAA, you know, things can change. So it's amazing, but your mileage may vary. one that I've been using a lot lately is Objection, and this is again based on Frida, and it's got a lot of these scripts just pre-built for you. Now I use this in two different ways. I'll use it when I'm actually looking at an app and I want to go through and, if I want to disable SSL pinning, then I just do one command and it does most apps, right? Unless it's those big budget ones, again, it'll get the job done. The other thing I do with them is their code is all on GitHub, right? All of this stuff is public. So I'll go out and I'll look at their scripts. When I can't get something to work, I'll look at what they did, and I can generally take a small piece because I'm not a serious programmer. So, when you're passing a function into a function and returning a function, like my brain starts to melt a little bit and things go south. So now we get to the good stuff, right? So I'm going to try and show a little bit of the basic environment because it's kind of neat. So I'm just going to flip over to command real quick. Just kidding. So I'm going to mirror my screen so that I can see what I'm typing. Can you guys see that okay? So, let me pull that up a little bit. That's better. So, I'm already in my virtual environment. That's what this Frida tag is. I have a link included in my resources in the slides that'll go out that have a bash function, so I don't have to remember the whole command line. I just say VE activate and choose the name, right? So you can get that from the slides. So I have an Android Pixel plugged in right here. I use the Pixel because they're super easy to root, and you can get them on Amazon for like 200 bucks. All right, so I know my app is running. So Frida's going to do, Frida will spawn the application like I said. So you can't see it because Reflector is really unhappy when you're plugged into an external HDMI. Right, so I'm just going to spawn the app and it's going to do nothing. Right, so you can see. I'm not going to open it all the way because we have to listen to it. Right, so one of the cooler things about Frida, right, there's a billion options to the API, and I don't want to remember them all. So it has command completion. Right, so oops. That's super helpful when you're just learning and poking around, right? Like that's extremely helpful. I did this one on purpose, right? Because I wanted to show that even though this is a 64-bit OS, the application is 32-bit ARM, right? And I was not expecting that, right? Like I just assumed 64-bit, all the apps would be, but they're not. And so I also learned that you can't always rely on that, right? Because apps will report things differently. So one of the best ways to see what you're working with is your pointer size, right? If it's a 4-byte pointer, 32 bits. If it's 8, it's 64. So I always look at the pointer size when I'm looking at a new app. When I was initially trying to get Stalker to work on one of the apps I first did, I beat my head against this forever because I thought I was working with a 64-bit app. So now I'm actually starting to look at the inside of the application, right? So this is a fairly big app, right? It's got a lot of modules loaded, okay? A lot of modules loaded. gaming. Right. So there's your base address running in memory, and that again does not take a reverse engineering wizard, right? So if you've got IDA, or if you're good enough with one of the other tools where you can find the functions that you're looking for, it is very quick from this point to get the offsets and start altering those functions. Mobile apps work a little bit differently from a desktop app. When you start doing research and learning on Frida, a lot of the demos are going to show desktop apps, x86, x64, because they're easy to demo, right? They have a main injection point. Android apps don't do that. They've got a bunch of intents, and the manifest sets up sort of a bunch of mains. And so it's more difficult to kind of flow through what you're looking for from the entry point. So I'm running out of time a little bit here, so I'm going to show you the other one that I like even more. So let's make that bigger. So objection, I don't know which second one. So I'm in objection, right? So this is a wrapper with a bunch of scripts already made for Frida. And so if you don't have the jailbroken devices, go through the effort of trying to figure out how to get the gadget in there, because it's very powerful once you have that in there. You can't do much. You can still talk to the phone, and you can still do a little bit of kind of exploration, but you can't do all of the ejection, and you can't do all of the stalking without the gadget, right? So objection is expecting the TAC-G. Now, since I'm running on a rooted device, I don't need the gadget, but that's just what it's called, right? So then you just call explore. And objection needs the app to be running already. It doesn't do the spawning, right? But it also has a very cool command completion, and actually will give you some kind of description there. So like, right? These are the activities on the apps, which you can think of as just like the different screens, the different, almost like tabs in Chrome, right? And so this one doesn't have too many. You know, obviously we're looking at the Candy Crush Saga activity, but here's where you can really start doing some more exploration. Right? List classes. It's going to take a second. Right? So you can see these are all the classes that are loaded resident in memory for all of those modules that we looked at. Right? So again, just copy this out and start looking for the ones. Scroll. So like, it's the Java naming conventions. So backwards, com.king.candycrushsaga.gameview, right? I know that's the one where most of the game activity is taking place for the management and the control of the menus and stuff like that. And so, once you find the class that you want to start looking at, and you're going to do this over and over again recursively. You're going to find a class that you think is the right one, and it's not going to be the right one. But you can list the methods for that class. Oops. Right, and so if you saw what I just did there, right, I didn't have to type that all out because I had done it previously. Objection just remembered it, so I could just hit tab and it got it. Right, but so that gives me all of the private, public, and static methods for that class. Right, so now you're starting to look at what's actually running on the inside of this application. So you can find the names of the methods by doing this, and that's when you start, discovering the offsets. Now you can load functions by name in your script if you've gone through all this, but you have to do this work first. Now, one of the problems with this one, and I kind of went all in on Candy Crush for this demo, and learned later, as I was failing, that they call C++ code from inside of here. So the cool stuff that I wanted to show on screen, where they make their money, is in C++, right? So that's another level of protection and sort of abstraction. And we don't know if they did that for performance or for protection, but that's another level of reverse engineering that objection is not currently set up to do, right? Like it's a lot of just kind of figuring things out and banging on this. So let's go back there, not that, go back there. So obviously I did none of this myself. I am standing on the shoulders of giants. All of the thanks for free to goes to Ole Andre Badlaravnas. I'm very sorry, sir. But he's the genius behind all this, and he's an amazing programmer. I do have, oh, you know what? There we go, wrong button. So there are a bunch of communities that you can go talk to. Like I hang out in the iDevice Pwn, which is for jailbreaking and rooting. And then the secret Slack, that's the guy that wrote the Frick debugging tool. And there are a lot of really helpful people in there. So when I ask questions, you know, it's kind of like IRC in the 90s. So if you ask a pointed question, how do I do this one thing, 4 people will try to help you. But if you go in there and say, lol, how do I hack mobile apps, they're going to ignore you. Right, so they've been very helpful. The Freenode is basically just a mirror of the Telegram. So ask me some questions. Anyone? No. No, go ahead.
You talked about the second level of the C++ abstraction, and basically what you do with that. So adding a base real,
Right, so I would have to extract that module off the device, and at least that's what I would do. There may be a way to do that scripted-wise, but I would have to extract it off the device and run it through Binary Ninja or something like that. There's another question back there?
When you do the search in Frida, it used to generate JavaScript stubs for everything that it does. And you said you can do Python and everything now, but when it stubs out all the functions,
Yep.
does it still only do JavaScript, or does it stub out other languages?
It does not stub out the other languages. And honestly, I don't see a lot of usage of the stubs anymore. Like you're talking about when you run free to trace and it will build a JavaScript file and tell you the location and say, okay, go edit this file without closing Frida or your app, and it will do it live. So you keep editing that file and you'll see the effects change in the running application, right? So if you're doing it the other way with the static scripts, then that doesn't work, and you have to write it all yourself. But like that Python script I showed, that's all you need to set it up. So you don't even really need the stubs. So, yes?
Have you ever tried the React Native or Xamarin?
I have not. It'd be a good question to ask. I mean, I could ask on the Slack channel right after this. And you mean as a target, right? So trying to figure out. So I mean, it's as long as it's x86 or x64, I wouldn't see a problem with it. I know people use Frida for all kinds of stuff. So. Yep. Anyone else? Yep, back there.
What's the preferred way of dealing with like obfuscation, like Trogar?
Right, so a couple different things, right? So static code obfuscation, right, is almost all manual. So like they said in the other talk, I'll use JADX or I'll pull it off, and with an iOS app I'll pull it off and do it the hard way, but it's manual. You know, I use Visual Studio Code, and it's really good at remembering or at tracking the symbols. So if I rename this variable right now that's just A to something meaningful to me, it'll catch that symbol across other classes where it's used and rename all of them, right? And then with running code obfuscation, runtime obfuscation and protections, then it's just like it's like whack-a-mole. You have to figure out what they're doing, right? Anti-jailbreak or jailbreak detection and anti-jailbreak detection, right? It's the exact same thing. You got to figure out what they're looking for and tweak that function in your script so that before you get to the money maker, you set up your, I don't want to say stack because that's a specific word, but you set up your flow to get there. Right. Anyone else? Nope. Well, thank you very much.